Hi there, I'm just going to go over the answers to the graphing gradient functions worksheet. We'll start off with the very first one here on the graphing the gradients worksheet, which is a straight line. Now the straight line has a gradient of rise over run, which means that we can work out this gradient. If I come over to here, we can work out this gradient of that distance by this distance up here, which is just that there is just your rise over the run. Now the gradient across here is 1, 2, 3, and it goes up 1, 2, 3. Therefore it's a gradient of 1. That means that I can actually draw in this here. It is actually a horizontal line going at 1. Right, look at this one here. Now if I have a look at this one here, we've got a gradient first going down here. We've got a gradient first that's actually negative because it's going downhill. Then we've got another gradient which is actually going across here, and that one there is 0. That gradient there, just like drawing a tangent line to there, is actually 0. And then if we look at what's happening with the gradient going up here, it's now positive. So you start with a gradient which is negative, then at that point there is 0. So what I'm going to do is I'm going to go, I know it's 0 at that point there, so I come right the way down, make sure it lines up to here, and I'm going to put a point right at the end of it, and I'm going to put a point right here, and at that point there I know that it's going to be 0. Now I also know that it is going to be negative coming down here, and also getting more strongly negative, and up here it's positive and getting more strongly positive. Therefore I can actually draw this gradient, and this gradient will actually be a straight line going up. Right, next one that we've actually got. This one here, we've got several different gradients. We've got a gradient coming along here which is actually positive. Then we've got another gradient coming here which is slightly less positive. Then we've got another gradient which is 0 at that point there. That point there is 0, so that gradient there is 0. And then again we get a gradient, and it's getting positive, and it's becoming more positive. So it goes positive. It starts off positive, which is over this side here. We know that at that point where we've got here, which is called the point of inflection, it's going to be at 0. So if we actually draw that, it's going to be at 0 here. We know that it's positive out here, and it's getting increasingly more positive, and on this side it's positive, and it gets increasingly more positive. If we draw a nice smooth curve through this, and then up the other side, we have got the gradient function. Right, now let's have a look at this other one on this other side here. Again, we've got gradients. Starts off positive. Okay, the gradient of there is positive. Then at this point here, the gradient is 0. That point there, the gradient 0. And this point slightly down below here, that gradient is also 0 at that point there. So what we'll do is we'll go, right, it's 0 at this point, so we'll just bring down a line to here to make sure we graph it in the right place. It's 0 at that point, and at this point here it is also 0, so we're going to bring it down to there. So we know at those 2 points that at this point here it's got to be a 0, and at this point here it's got to be a 0. So wherever we've got these humps there and there, we know that we're going to have 0 gradient at those points. This point here and this point here is 0 gradients. Right, this here is coming down, it's going down, and that is the maximum negative that it's going to be. That there is called a point of inflection. This pen really doesn't write that nicely, but it's called a point of inflection. Right, so what I also want to do then is I want to grab a line from there and take one straight down as well. Go right the way down and go right. That there is going to be my maximum negative point. So that is as far down as I'm going to go negative. Alright, so that there is as far as I'm going to go down negative. And when I have a look at this, I've gone down around from the top, because I've got to get some idea of how far down to go. I'm going down here, I'm going down actually 12, and then I'm going across from about 1 all the way across there to 3. So I went down 12 and across 3, so therefore I'd be at about -2, -4. So I'd say about -4 is the lowest that it's going to go. So I actually had a look roughly about what that line down there was going to be. This line coming straight down here. And I realized it was down 12 and across 3, so I've got an approximate gradient of -4. So that is as low as it's going to go. You've got to get some idea of roughly how far down it goes. Now we know it's positive at all these other places. We know that it's positive at these places. Therefore, if we just draw a nice smooth curve through it, which is very difficult with this pen. Okay, so this is a cubic, and you can see that this one here is a parabola. Right, now we're coming to the slightly more difficult ones. Again, we look at the key points. Now the key points here are when you've got these humps, which is going to tell me that my gradient is going to be 0 at each of these humps. So there it's 0, so my gradient's also going to be there 0, and my gradient is also going to be there 0. So at those points there, I know where I've got it on my graph. I know that I've got a 0 here, and I've got another point here, and I've got another point here. Those 3 points is going to be 0. Now, if I start looking at some of these other tangent lines, I know at this point here is a point of inflection. It's changing from concave up to concave down, so that there is my maximum positive line. So I'll just make that a little bit bigger. That is my maximum positive line. So it's going to be along here. That one's a little bit crooked. Okay, so it's going to come straight down. It's going to be my maximum positive line from there. Right, what I have to do is find out roughly how high that's going to be. So I look at that, it's about -2, and I come across here. That's this one goes down to around about -12, and it comes up to about 8. So that distance there is about 20. So this distance that we've got from this top part here down to the bottom part there, that there looks from around about 8 all the way down to -12. So that there is approximately, it doesn't have to be accurate, but that there is approximately 20. And then I go, okay, I've gone from -2 over to about 0, so that this distance here is around about 2. So therefore, the gradient of that line there, coming down there, is approximately 20, which means, it's approximately, the gradient is m equals 20, the rise, over the run 2. So that means that that gradient there is approximately 10. So it would go through there. Right, this point here is quite negative. So it's going to be very highly negative, so that means it comes right down the bottom here. So it comes up, it's going to be very highly negative, goes up, goes to the maximum, and then comes back down. Now, at this point here is again another point of inflection. That's where it changes from concave down to concave up. That there is going to be the maximum negative number. And I'm going from around 8 to this time about 4, so I'm going about 12 and across 2. So that means this time I'm going down here about 12, and I'm going across about 2, which means the gradient of that point, m, equals 12 over 2, which means it's going to be about 6. Remember, it's -6 because it's going downhill, which means that this here will come down, I'll find my point, come down to around about -6, about there. So it's going to come back down, and then it's going to come back up because my gradient's getting steeper again here. So this here is actually a quartic to the power of 4, so this one here will be looking like a cubic to the power of 3. Down and back up again. Right, on to our next one. Again, what we look for is we look for our turning points. And our turning points are where the gradient is going to be 0. So there's our first turning point. Gosh, these lines are really not playing nicely with me. Okay, so there's our first turning point. This one here, I'm just going to delete that. Okay, I'll do it on here. That is my first turning point, this point here. So if I actually did that, came down, directly down, I know that that point there is going to be 0. Okay, got a bit of a problem here. I should have changed the axes on this one as well, so I'm just going to assume that these axes are actually the same. That's going to be my other point, which will be 0, which will be about here, and this will be my other point here, which will be 0. Remember it's 0 because I've got 0 gradient at these points here. They're just going flat across. This point here, it's positive. The gradient is going up. Okay, so we're going uphill, so that means it's positive, and it's pretty highly positive. And it's coming down to be less positive. And at that point there, it is 0, then it is negative, and at that point there, point of inflection, it's going to be a maximum negative. Again, you have an idea, it's gone from about 4 down to around 6, so it comes down here around about 10, and it went across from about 3 to about 1, so it's gone across about 2, so therefore the gradient of that line down there is around -5. So the gradient of that, m, will equal 10 over 2. Of course we're going downhill, so it's minus, so therefore we know how far it's going to come down. It's going to come down all the way to about -5 and then come back up again. Right, then we've got our next point of inflection, which is approximately here. This time again, this is about -6, goes all the way up to about 12, so it's coming up 18, and we're going across about just over 1. So that again, this gradient here is all the way is 18, and it's gone across only around it's gone across from here all the way over to there, so you've gone across about 2. So that distance there is about 2. So therefore the gradient of that is 18 over 2. So it's around about 9. So this is going to come all the way up to around about 9, about here. Okay, so again it comes up, and then again it goes back down again. So in other words, this thing will look something like this. Whoa, it's really hard to draw this nice and smoothly. Anyway, you get the idea. Anyway, that's graphing the gradient functions. In the next video, I will go over how to graph functions given the gradient function, actually coming back to actually graphing the function. So if I just go over with these last two here very clearly, what do you need to know? You need to know these points here, at those points there, and here, and all the way down to there. Those ones there tell you where your 0 points are on your gradient. So straight away you can always graph your 0 points on your gradient. Same as we've got these points over here, there, that gives us your 0 point, another 0 point, another 0 point, and another 0 point. Okay, so I'll leave those ones for a later time.